Hello, today is Monday, November 29th, 2021. I'm Joe Schmidt from TC2, and this is Staying Connected. If you have an interest in 5G wireless technology like I do, you are going to find today's podcast fascinating. You see, there's currently a dispute between the wireless communications industry and the aviation industry, or should I say a dispute between their respective regulators, the Federal Communications Commission, the FCC, and the Federal Aviation Administration, the FAA. These are two heavyweights for sure, and they appear to be having trouble, at least for the time being, on how to work cooperatively so that new 5G wireless services are rolled out and the aviation industry continues to operate safely and on time. This is a legal and a technical conundrum, so I am very fortunate to have with me today Steve Rosen, a partner at LB3, and TC2's technical director, David Lee. Hey guys, thanks for joining me. So David, let me start with you. We've covered 5G on a few podcasts over the last year, but I'd like for us to get a better understanding of the technologies that underlie this tense regulatory and economic situation. Now, I know that it's been, probably a few years, but since you studied electromagnetic fields, but can you tell us more about the 5G mobile wireless and radio altimeter technologies that are at the heart of this impasse?
Good to be with you, Joe and Steve, and yes, I would be happy to. First, 5G mobile wireless is shorthand for the most current or fifth generation set of cellular standards and services. These services are expected to provide much higher data rates to end user devices and perhaps more importantly, a means of providing connectivity services to Internet of Things devices, which now include virtually every new appliance, toaster, oven, self-driving motor vehicles with high-speed Internet access. And although 5G services operate in many different frequency bands, as a general rule, they will operate at higher frequencies compared with third and fourth generation mobile wireless data services. Use of these higher frequencies allows for greater data capacity, but requires the construction of more transmitters and base stations because higher frequencies, such as millimeter waves, do not propagate as well as lower frequency waves. The 5G spectrum at issue in this case is located in the C-band, or 3.7 to 3.98 gigahertz, which has 220 megahertz separation from the 4.2 gigahertz at the low end of the radio altimeter band, and we'll talk about what a radio altimeter band is. This C-band spectrum, by the way, is extremely valuable to 5G providers such as Verizon, AT&T, and T-Mobile because it strikes the sweet spot between high data capacity and good propagation characteristics.
Okay, right. I understand the 5G bit, but I don't see why radio altimeters have anything to do with 5G.
Joe, that's a good question. Radio altimeters, or RAs as we're going to refer to them today, provide pilots and the aircraft's height above the ground, day and night, and in all weather conditions. They serve as an aircraft's eyes for ground collision avoidance. They also provide critical data inputs to the airplane's autopilot, automated landing systems, and the ground proximity warning system, or GPWS as it's called, which is intended to prevent FAA-controlled aircraft crashing into the ground, which is as bad as it sounds. Largely due to the mandatory use of RAs and GPWS, there have been no controlled aircraft flying into the ground among commercial jet aircraft in the U.S. for 47 years now. RAs are also essential safety instrumentation to helicopters, including medevac helicopters that often operate at night, in bad weather, and in difficult terrain. But as either fate or Murphy's Law would have it, these radio altimeters have also operated in the C-band, or more specifically at 4.2 to 4.4 gigahertz, which in electromagnetic terms is close to the newest 5G allocation at 3.7 to 3.98 gigahertz. And RAs operate by bouncing a radio wave off the ground, and based on how long it takes the bounce signal to return to the RA, calculates the altitude. It's important to note that by the time the signal returns to the RA, it is very weak, so the RA receivers in the aircraft may be susceptible to interference from nearby frequencies. Note that this is not just a U.S. issue. The RA frequency band we just spoke of is allocated for that specific spectrum globally, and the RAs and airframes in question are deployed worldwide.
Okay. So now we understand the physics. So, Steve, as the lawyer, perhaps you can explain the apparent conflict between the aviation industry and the communications industry and their regulators.
Absolutely. And it's good to be back with you, Joe and Dave, and I hope you enjoyed your turkeys. So let's start with the regulators. The FCC is an independent agency, meaning that although the commissioners are appointed by the president and confirmed by the Senate, the FCC is not part of the executive branch of government. The FAA is part of the Department of Transportation, an executive branch agency headed by the Secretary of Transportation. So the FCC and the FAA are both quite expert in the industries they regulate, but the cross-agency nature of the radio altimeter 5G interference issue has made resolution of the issue difficult, if not impossible, if the agencies do not work in harmony. And unfortunately, they have not totally cooperated to date.
Right. So it sounds like this system with the agencies was always going to fail. How has this played out at the FCC and the FAA?
Well, a good starting point is February 2020, when the FCC conducted a notice and comment rulemaking culminating in a report and order that reallocated the 3.7 to 3.98 gigahertz slice of the C-band spectrum from satellite services to 5G services. The aviation community, consisting of avionics manufacturers, airframe manufacturers, the airlines, and pilots, filed comments expressing concern about interference from wireless devices at 3.7 to 3.98 gigahertz to radio altimeters at 4.2 to 4.4 gigahertz. As evidence for its position, the aviation community cited, among other things, a Radio Technical Commission for Aeronautics, or RTCA, report that, based on a number of usage category simulations, calculated that interference between 5G facilities and radio altimeters can occur and urged further experimental study. The wireless industry disputed the RTCA findings but did not enter any of its own studies into the record. Based on the record evidence of interference, in May 2020, the aviation industry filed an FCC petition for reconsideration, asking the FCC to reconsider its earlier opinion and convene a multi-stakeholder group of the aviation industry, the communications industry, the FCC, and the FAA to agree to mitigation requirements to prevent interference. But the FCC did not act on this petition for reconsideration, and in February 2021 raised $81 billion for the U.S. Treasury by auctioning the C-band licenses to AT&T, Verizon Wireless, and T-Mobile, and they set December 5th as the date the carriers may turn up their new C-band specific 5G services. Likely, there's more pressure on AT&T and Verizon to roll out a suite of 5G services, as T-Mobile has already deployed 5G services at 2.5 gigahertz throughout the United States.
Steve, December 5th is next week. Will the carriers actually turn up the C-band 5G service on December 5th as scheduled?
No. In early November, this interagency and inter-industry conflict finally arrived at the doorstep of the National Economic Council, or NEC, an executive branch agency given the thankless task of refereeing this type of dispute. Likely, one of the developments that pushed the NEC to act was the credible threat that the FAA would close various commercial airports to instrument-only approaches, which are necessary at night and in bad weather, if the FAA could not have assurances that the 5G C-band deployment would not interfere with radio altimeters. Of course, closing these portions of the national airspace system would be disastrous for both airline passenger travel and air cargo service. Perhaps under pressure from the NEC, in mid-November, AT&T and Verizon Wireless agreed to defer their 5G turn-up until January 5th of next year. Since then, there has been a flurry of activity at the FCC by both the wireless industry and the aviation industry. The wireless industry has urged the FCC not to deviate from its original findings and not defer the service initiation beyond January 5th, based in large part upon the wireless industry's contention that 5G has been deployed internationally without radio altimeter interference. The aviation industry has countered that the overseas deployment of 5G services is based on different power levels and frequencies, and some foreign nations, such as Canada and France, actually have required cellular carriers to implement mediation measures near airport approaches. The aviation industry has also filed additional interference studies with the FCC. Finally, on November 24th, AT&T and Verizon Wireless made an FCC filing in which, while stating that they did not believe that C-band 5G would interfere with radio altimeters, After consultations with the FCC staff, they nevertheless voluntarily agreed to implement nationwide power limitations and even more restrictive power limitations near airport runways, final approach patterns, and heliports until July 6th, unless credible evidence emerges that real-world interference would occur if the measures were relaxed. Initially, the FCC and the FAA have both reacted positively to these mitigation measures, but have yet to make their final regulatory determinations that these measures will be sufficient to prevent interference and ensure air safety and/or press for continued negotiation between all stakeholders.
You know, Steve, this is an interesting dilemma that will be watched by us and by enterprises. Let me note that several of our clients have plans to use 5G as secondary and tertiary connections at sites, and some even plan to use them as a primary connection. So, Steve, what should enterprises do? Stay tuned?
Yes. Enjoy your uninterrupted Christmas and New Year travel while keeping your phones in airplane mode while aloft. And stay tuned as we count down until July 6th and see how the FCC and FAA and aviation industry and communications industry all hopefully work together to finally solve this problem.
Okay, thanks, Steve. And David, thank you as well. This is a pending regulatory and economic train wreck if things don't get sorted. So we'll keep you updated. In the meantime, if you do want to talk about 5G or other ICT topics, you can contact Steve, David, me, or any of our LB3 and TC2 colleagues by giving us a call or dropping us an email. You can also stay current by subscribing to these Staying Connected podcasts, checking out our websites, and by following us on LinkedIn.